Mr. Sutton here, bringing you the Algebra 2 6-3 Part 2 homework solutions on logarithms and logarithmic functions. In this one, we're focusing on evaluating logarithms and simplifying logarithmic expressions, with and without a calculator. For the first several problems, we're going to be evaluating the logarithm without using technology, so just doing it in our heads. So here we're asking, if I'm doing log base 3 of 81, I'm asking, what do I have to raise 3 to in order to get 81? Well, let me think of 81 as a power of 3. So 81 would be 3 to the 4th power. Therefore, log base 3 of 81 is just that exponent of 4. On this one, I'm trying to figure out log base 3 of 3. So I'm basically asking, what do I have to raise 3 to in order to get 3? Well, I know 3 to the 1st power is 3, so log base 3 of 3 is just 1. This problem, I'm asking for log base 5 of 1 over 625. So 5 to the what power is 1 over 625? I don't know off the top of my head, but I know that 625 itself can be expressed as 5 to the 4th power. And if I want this to not be a fraction, because my base is not a fraction, I can make this not a fraction by writing this as 5 to the negative 4 power. And that tells me that the exponent I have to raise 5 to get 1 over 625 is negative 4. So that's what my answer is for log base 5 of 1 over 625. The answer is negative 4. On this one, we want log base 4 of 0.25. So I'm going to turn this into a fraction just so I kind of have a better idea of what I'm dealing with. This is really the fraction 1/4. And so I'm basically asking, what do I have to raise 4 to get 1/4? Well, 1/4 is really 4 to the negative 1 power, right? So that means log base 4 of this 0.25, or 1/4, is just negative 1. For the next few problems, they want us to evaluate a logarithm using technology, round to 3 decimal places. Our first one here is log of 6. So this is just log base 10, which is built into all scientific calculators. Going to Desmos, I just have to write log and then 6. And it tells me what do I have to raise 10 to get 6? Why, I have to raise it to 0.778 and some change. For this next problem, they want log of 0.6 plus 1. So let me just go in there and enter that in. So we have log of 0.6 and then plus 1. And the order of operations means that this log of 0.6 is going to happen before the plus 1, which you can verify if you want. But we end up with 0.778. And you could always use a parentheses around the 0.6 if you were a little bit worried about that. For this problem, they want the ln of 1/3 using technology. So let me go to Desmos, and let me just type in ln. And to get the fraction in there, let me just try and see what happens if I do it this way. So 1 divided by, nope, see, it wants to make this whole thing into a fraction. All right, so here's a workaround for this. If you open a parentheses and then you do 1 divided by 3, it'll put the fraction inside the ln, and that comes out to negative 1.099. For the next few problems, they want us to simplify the logarithmic expression. So here I have a 10 that I'm raising to a log base 10 of 4. Since the bases are the same, they're going to cancel each other out, and I just end up with 4. To simplify this expression, we have to recognize that we're raising a base to a log with the same base, so the 7 and log 7 essentially cancel out, and I just end up with x. To simplify this problem, I just need to recognize that I'm taking a log with the same base as the exponential term inside. These are both base 3. So those, the log 3 and the 3 to the whatever are going to cancel, and I just get the exponent inside here, this 2x. On this problem, I'm taking a log base e of e to the negative x. That's what ln is really doing here. Since my log and my exponent base are the same, that means that I'm just going to get whatever was inside the exponent, which was negative x. Though the log and the base cancel each other out. For this one, they're talking about skydivers. They say they're using an altimeter to track their altitudes as they fall. The altimeter determines the altitude by measuring air pressure, interestingly enough. So the altitude is related to the air pressure by this function here. And the air pressure is in pascals, whatever those are. So we want to know the altitude above sea level when the air pressure is 57,000 pascals. So apparently you plug the air pressure in here and it figures out how high above the ground you are. That's kind of cool. So all we have to do then is replace P with 57,000 and calculate this out. So let me go to Desmos. I'm going to plug this all into one shot right here. So negative 8,005 times the ln of, let me do a parentheses and then a fraction. We've got 57,000 over 101,300, and you don't want to use commas on Desmos because that's not how calculators work. Close the parentheses, and it looks like that's coming out to 4,603.16 if you want to round it off. And that's going to be in meters. And actually, if I'm rounding it off, let me make that 403.2. There we go.